Okay, let's unpack this. Imagine taking, these old black and white photos from decades ago,
Hmm.
the kind that show us exactly what the Earth looked like from the sky, maybe before many of us were even born, and somehow bringing them to life with color. That's the really fascinating idea at the heart of this deep dive.
Yeah, we're looking at notes here from a consultation about a specific AI project trying to do exactly that,
Yeah.
colorizing historical aerial photographs.
Right. So the core mission, it seems, is taking these old grayscale images, mostly from before 1981.
That's right. We're talking data from the 1950s, 1970s specifically.
And adding realistic color. But the tricky part is the only original color data they have to train these AIs is from 1991. That feels like quite a leap visually and, well, technologically.
It is. And the reason they want to do this isn't just, for looks.
Right.
The goal is really to make those old images useful for modern analysis, specifically to help with automated classification.
So teaching computers to spot things like buildings, roads, forests.
Exactly.
Yeah.
Identifying features in historical imagery, just like they can with modern color photos.
Okay, but here's where it gets really interesting, I think. It's way more complex than just hitting some kind of auto color button in software.
Oh, absolutely. They're using advanced AI models, and the notes show they've hit some very specific, pretty stubborn roadblocks.
It really highlights the challenge, doesn't it? Trying to teach an AI the sort of subjective reality of color based on, well, limited, imperfect historical grayscale information.
It's a huge challenge.
So for this deep dive, we're going to zero in on the technical hurdles they actually ran into and the ingenious solutions proposed in these consultation notes. It's a look inside the kind of messy, creative process of applying cutting-edge AI to messy historical data.
Yeah, a real deep dive into the art and science of imagining the past in color.
All right, diving in then, what kind of AI tools were they initially leaning on to try and pull this off?
So they've been working with the kind of powerful architectures you'd expect for image tasks like this, generative adversarial networks or GANs.
Right, GNs. Heard of those.
Specifically, the notes mention PixHD and also UNets.
Okay.
GNs are often great for generating complex outputs, like, realistic-looking images. And UNets are really strong when you need that precise, pixel-perfect mapping from the input to the output.
And they weren't just using standard setups, right? The notes mentioned they had already tried things like histogram matching.
That's right. Which is a smart move. It helps adjust the overall tonal balance of the black and white images.
Okay.
The idea is maybe to align those older tones better with the grayscale characteristics of the 1991 color data they're using for training. You need some consistency across different eras, ideally.
And they added a color loss function. What's that about?
Correct. So that's a specific technique you use during the AI training. It's designed to penalize the model when it produces colors that seem unrealistic or inconsistent. It essentially gives the AI a stronger signal about what good or plausible color looks like in this context.
So they've got these sophisticated models, some clever initial techniques, all aimed at turning grayscale into believable color so that, crucially, a later classification model can make sense of it all.
Exactly. The success is really measured by whether the colorization makes the historical imagery interpretable for machine analysis, sort of mimicking how we analyze modern color imagery.
Okay, so despite these efforts, where are they actually running into trouble? What are the specific, pain points the consultation notes highlight?
Well, the notes are pretty clear on this. Well, the vegetation colorization is actually looking, surprisingly good.
Green trees are easy.
Relatively speaking, yeah. Green trees, forests, they seem relatively straightforward for the AI. But the big problems pop up when it tries to color buildings and water, especially smaller areas or features with fine details.
Like rooftops, maybe sports fields, that kind of thing.
Precisely. Yeah, those smaller, distinct areas are proving particularly stubborn.
And what does that look like in the images? Are the colors just wrong? Or
You see errors like uneven patches of color on a single rooftop, or just completely incorrect colors showing up where they shouldn't be. It's like the AI just can't quite figure out the boundaries, or maybe the specific texture it's supposed to represent.
That's fascinating. You wouldn't immediately think roofs would be the hardest part. Why is that so difficult?
Well, the notes point out a key reason. Roofs in the real world have incredibly diverse materials and colors, right?
Sure. Tiles, shingles, metal.
Exactly. Red tiles, gray shingles, shiny metal, sometimes even green from moss or algae. But in a black and white photo, many of these can look like very similar shades of gray.
Ah.
So the AI really struggles to reliably guess Say, a bright red tile roof from a medium gray tone, when that same gray tone might represent asphalt or concrete somewhere else in the image.
Ah, okay. The same grayscale value can mean wildly different colors in reality. That makes total sense now.
And then compounding this with their Jan approach specifically, they mentioned seeing color instability, meaning you train the model multiple times with the exact same data, and you can get significantly different colors in the final output image each time.
Oh, wow. That makes the results really unreliable, especially for that classification task later on.
Totally unreliable. And let's not forget the fundamental challenge of the source material itself. I mean, these are old photos.
Right. Not exactly high-res digital snaps.
Absolutely. The historical black and white photos just have inherent quality issues. Graininess, maybe limited original resolution. The AI is simply working with less information from the get-go, which makes guessing color accurately much, much harder.
It's like trying to color in a blurry, noisy sketch instead of a clean line drawing.
Exactly. Plus, the notes mention that the grayscale distribution itself, just the range of blacks, whites, and grays, can vary between decades. A photo from 1950 might just look different, have a different overall brightness or contrast profile than one from 1970, even before we think about color.
And that variation makes it harder for one model to work well across all the different years.
Yeah, it impacts the model's ability to generalize across the entire data set.
Okay, so we have models struggling with specific details like roofs, unstable color generation, and then this imperfect source data with inconsistent properties. That's quite a list of challenges.
It is.
So how did the consultations suggest tackling these? What were the potential solutions put on the table?
Well, the consultation notes proposed several really intriguing ways forward. One idea that came up quite strongly was exploring ways to better integrate the classification or segmentation goal more directly into the colorization process itself.
Okay, so instead of just colorizing and then trying to classify what's in the picture, doing them sort of closer together or at the same time?
Precisely. One specific suggestion was joint training.
Okay.
This basically involves training the colorization model and a segmentation model together simultaneously. The notes mention potentially using an existing segmentation model, maybe one from OpenEarthMap, which is a great resource for this kind of Earth observation AI, possibly using it as a component. Maybe even acting a bit like a discriminator in a Jan setup, but focused on judging segmentability as well as just visual realism.
Okay, so the AI isn't just trying to make pretty colors, it's actively trying to make colors that are also easy for another AI to understand and classify correctly. That's kind of forcing it to be functionally realistic.
Exactly. It ties the technical colorization task directly back to its intended purpose. And related to that, another strategy they explored was putting segmentation first.
How would that work differently from joint training?
So here you'd use an existing segmentation model again, maybe an OEM model known to be good at identifying things like buildings and water, to first process the original black and white image. It would essentially create a map identifying where it thinks the different objects are.
It's like outlining the buildings, the water bodies.
Yeah, exactly. And then you feed that map, along with the original grayscale image, into the colorization model.
Ah, so you give the colorization AI a hint, basically. Look, this specific area you're about to color, that's a building. This bit over here, that's water.
Yes, that extra context, that hint, should dramatically help the model color the borders and the details more accurately. It specifically addresses those problems they were seeing with, buildings and water bodies having weird edges or colors.
That's clever, giving the AI a head start on understanding what it's actually looking at. Okay, what about the issue of fine details, like you mentioned on rooftops? Did they have ideas for that?
Yeah, for those specific sort of localized problems, the notes suggested trying a regional focus during training.
Meaning?
Instead of always feeding the model these huge entire aerial images, you break them down into smaller sections or patches or tiles.
Training on little snippets of the image, how does that help with things like edges or roof details?
Well, the thinking is it allows the model to learn specific fine-grained features within those small areas more precisely. For those really tricky details on building edges or subtle grayscale variations on different roof materials, training on smaller patches might help the AI become much better at interpreting those localized patterns and assigning the correct, consistent color.
Okay, so some ideas are about how the models work together or how they focus. What about improving the messy input data itself before the AI even sees it? Any suggestions there?
Yes, definitely. Several suggestions focused on pre-processing the original black and white images. One was enhancing edges.
Yeah.
The recommendation was basically to boost the contrast along object boundaries in the black and white image before feeding it to the colorizer, maybe using a standard technique like the canny edge detector filter.
So making the lines between things sharper, essentially.
Right. The theory is that if the AI can more clearly distinguish where one object, like a building, ends and another, like a road, begins in the grayscale input, it will have an easier time deciding where the color boundaries should be, potentially cleaning up some of those uneven colors they saw on things like rooftops.
Makes sense. And tackling the graininess issue head on, was that discussed?
It was. That led to the suggestion of maybe using super resolution technology as a first step.
Ah, like those tools you see online that magically make old fuzzy photos look sharper?
Exactly like that, yeah. The idea is to use AI to try and increase the perceived resolution and just generally improve the overall quality of the historical black and white images before you even attempt the colorization step.
So a cleaner, sharper starting image.
Should, in theory, provide the colorization model with more reliable visual information to work with, hopefully leading to a better final color result.
Okay, those are all really targeted solutions based on the specific problems they were seeing. Were there any suggestions to sort of step back and look at entirely different kinds of AI models altogether?
Absolutely.
Yeah.
The notes definitely recommend exploring other architectures beyond the main GANs and units they started with. Cycle GAN was mentioned.
Cycle GAN. I feel like I've heard of that. Doesn't it help with consistency somehow?
It does, yeah. Cycle GAN is known for what's called cycle consistency. It basically tries to make sure that if you translate from A to B, say, black and white to color, and then you translate back from B to A, you end up with something pretty close to your original A.
Okay.
And that property can potentially help improve the color consistency, which was one of the problems they noted with their current GAN approach.
But there's a catch.
The caveat noted in the consultation is that cycle GAN can sometimes be more complex and trickier to train effectively compared to some other GANs.
Right. And what about diffusion models? I mean, they seem to be everywhere right now for image generation.
They are, and the consultation definitely noted that. While maybe their initial attempts with diffusion models hadn't yielded spectacular results yet for this specific task, they strongly recommended continuing to explore and fine-tune them. Given how incredibly powerful diffusion models are proven to be for other complex image synthesis tasks, they hold significant promise if they can be adapted effectively to the particular nuances of historical grayscale colorization.
Wow. Okay. So they're really considering throwing the kitchen sink at this. We're refining the current methods, improving the input data, and looking at the absolute cutting edge of AI architectures. It's quite comprehensive.
It is.
But how do they actually know if any of these different solutions are, well, working? How do they measure success? That seems crucial.
Yeah, absolutely crucial. And that's where the evaluation methods come in. The notes suggested a blend, really, of objective and subjective measures.
Okay, let's take objective first. How do you quantitatively measure if a colorization is good or effective?
Well, the key suggestion was to use that downstream task, the classification task we talked about, as a benchmark.
Oh.
So the idea is, take an existing, reliable classification model, like that open earth map model mentioned earlier, one that was already trained on real, original color imagery, and then feed your newly colorized black and white images into it.
And you just measure how accurately it can identify the buildings, the trees, the water, and so on in those colorized images.
Exactly. The classification accuracy achieved on the colorized images becomes a quantitative score for how effective the colorization is. If the classifier can identify objects almost as well in the colorized historical images as it can in, say, the actual 1991 color images, then you know your colorization is functionally useful for the intended purpose.
That makes perfect sense, evaluating it based on whether it actually helps the next step in the analysis pipeline. But colorization also has to sort of look right to a human, doesn't it? It can't just be technically useful, but visually bizarre.
Absolutely. That's the other equally important side, the subjective evaluation. The notes stress that human judgment is crucial here.
So things like expert visual inspection.
Yes. Having experts, maybe remote sensing specialists or photo interpreters, actually look at the colorized images and visually assess them for realism. Are roads generally gray? Are forests green? Does the water look like water? They'd rate the images based on their visual consistency and overall believability.
And surveys, too, getting input from non-experts, perhaps.
Right, gathering opinions from different groups, maybe the general public, maybe specific map users, perhaps using questionnaires. This helps build more of a standard for how visually acceptable the colorized results are to humans in general. It acknowledges that the right color can sometimes be a bit subjective and ultimately needs to feel plausible to the people who will eventually view and use these images.
This is such a fascinating blend, isn't it? Hard technical metrics on one hand and human perception and judgment on the other. Looking ahead just a bit, did the notes mention any broader future possibilities or, research directions stemming from this project?
Yeah, they touch on a couple of potentially exciting spin-offs. One is the idea that the work they're doing on using segmentation before colorization, that could potentially lead to developing a generalized model specifically designed for segmenting objects in any black and white historical image, regardless of its source or original quality.
Oh, interesting. So creating a powerful sort of standalone tool just for understanding the layout of any grayscale historical photo, which other researchers or historians could then use for their own work.
Exactly. That could be a really valuable contribution to the wider field.
Hmm.
And the other ongoing need that was highlighted, perhaps unsurprisingly, is the continuous effort to collect and build more high-quality historical image databases.
Right. More data, better data always helps train these complex models better.
Precisely. It's really a foundational element for improving the AI's ability to handle the sheer variety of times, places, and photographic techniques that are represented in our historical archives.
So to kind of wrap this deep dive up, what we've really seen is a cutting-edge AI project running headfirst into the messy reality of imperfect historical data. They're leveraging powerful tools like GANs and UNets, but hitting these very specific, tricky snags with details like building materials, water bodies, and just plain old image graininess.
Yeah, and the proposed solutions we discussed are this really interesting mix of clever technical refinements like integrating classification goals directly, using segmentation as a guide, training on focused patches, improving the input data quality itself, alongside exploring the potential of entirely new AI frontiers like diffusion models.
And ultimately, the goal isn't just pretty pictures, right? It's really about bridging that gap between these valuable historical records and modern analytical tools, making the past more accessible and understandable for researchers, planners, or really anyone curious about how our world has changed over time. It's about adding color not just for aesthetic appeal, but for actual utility.
And, it really forces us to think deeply about what we even mean by realism when an AI is essentially inventing color for something it has only ever seen in shades of gray. Is the goal purely technical accuracy that can be measured by another machine, or does it also need to align somehow with human understanding, human perception, what feels right?
That's a great point to end on. For you listening, consider how applying modern AI to historical data like this forces us to blend that technical accuracy with human interpretation and subjective perception. What does it truly mean for an AI to understand and color the past in a way that is both technically sound and actually feels right to us?